What's happening, Hardscapers? Today we're going to talk about how you can build your own retaining wall. Let's get into this. If you don't know me, my name is Mike. I am the owner and operator of Ever After Landscaping in Ontario. I bring you these hardscape videos each and every week on the I Am a Hardscaper channel and host of the How to Hardscape podcast for hardscape business owners. But ultimately, my goal is to get hardscape information out there into people's eyes and ears so that they can put it to their own use. And today we're going to talk about how you can build a retaining wall by yourself using segmental retaining wall blocks. Specifically, under 3 feet. Usually anything over 3 feet in height above final grade is going to require permits and outside engineering. Now, I've owned and operated a hardscape business for more than a handful of years now, and a bit of that time was just by myself. So I've had to learn some things along the way that makes my job sites more efficient and is less taxing on me as a owner-operator. Anytime you hear this sound, along with some text at the bottom of the screen, that just means we have a full-length video on that specific topic, and those will all be linked in the description below to go much deeper into that topic. Starting with first and foremost in your segmental retaining wall block options. These days there's tons to choose from, different sizes, different shapes, color blends, and so many options from contemporary to more traditional rock face concrete blocks. Ultimately, the best thing to do is to go to a supplier and see their demos and get a feel for what aesthetic you like the most. Basically, there's two choices that you need to make, both the retaining wall block as well as the caps that will go on top. My own opinion is that I like to use a natural stone cap on top of my retaining walls. There's not many concrete product caps that I really like, and natural stone is just a beautiful way to cap any wall, especially because I can get 4 foot, 6 foot caps, and they're much larger and in my opinion just look the best. Another benefit to natural stone is if it chips or starts to wear down, it's natural stone all the way through it. The same can't be said for a concrete product. Once that starts to wear down or chips, it'll show the larger aggregate within the mixture. The next thing that we need to do is take a look at the design for the retaining wall product. And the best thing about this is that every manufacturer has their own engineered drawings of how you actually can build that wall to the height that you need it to be. This could include building that wall straight up. It could be a setback, so that wall actually is still level but angles in towards your actual retained area. And this typically allows you to build that wall higher, but it could also include Geogrid within different layers of that retaining wall depending on how high you're building it. Now, it's important to choose a retaining wall block that allows you to achieve the height that you need to build to. Not every retaining wall block has the specifications to be built to a certain height. So first and foremost, know the height that you're going to build it to above the final grade, and then choose a retaining wall block that meets your aesthetic appeal as well as the height to which you'll be building it to. Once you have all that figured out, you can now start to begin the excavation. A retaining wall excavation is going to be deeper than a paver excavation. If you're building a raised patio and you need a wall going around that raised patio, there's actually going to be a trench that is deeper for your wall than it is for the actual pavers. And this is because we need the same base depth, about 6 to 8 inches, that we would need for our pavers, but we also need to embed at least 6 inches of our first course of retaining wall block. If we use an example of a 6-inch base, we also need 6-inch embedment. That means 12 inches below the final grade is what we need to dig to. You can use a string line to set that final grade and then measure down while you're excavating from that string line to ensure you're at that 12-inch minimum. We'll talk about this a little bit later, but I do like to screed a bedding material on top of my base. It allows me to set my initial course of that retaining wall a lot faster, which means I also need to add an additional 1 inch of depth to this calculation because your bedding material should not be included in your base calculation. Now that's for the depth. In terms of the width of that trench, I need a minimum of 6 inches in front of that wall block, plus the depth of that wall block, plus a minimum of 12 inches behind that wall block. Or a rule of thumb is 24 inches from the face of the wall block to the back of the trench. With that calculation, it's a 30-inch trench that we need to dig for the whole length of that wall. When I'm excavating material, I like to have bins dropped in the driveway to dispose of all of my excavated material. I don't want to have to load up a trailer and drive to a dump it, come back, and continue this process. It's going to eat up way too much of my time, so I prefer the bin method. Now, if you want to know how much material is going to be excavated out, it is the length of your retaining wall in feet multiplied the width of the retaining wall trench in feet multiplied by the inches in depth multiplied by 0.003. That's going to give you an approximate cubic yards that's going to be excavated. You do want to add about a 15% fluff factor to that and then plan your bins accordingly. Now that's just for the trench, but you might also be cutting into a slope and you'll want to add more to this calculation to account for that material in the drainage area behind the wall that you're going to also be removing. Now by this time we're already down to our subsoil, which should be a clay or sandy mixture subsoil. You should have no organics. Once we're at our subsoil, I do like to compact a layer of 3/4 inch clear stone along with a type S mortar mix for clay or Portland cement for a sandy subsoil. This helps draw out the moisture from that and gives us a good subsoil to start to build on top of. At this point, I like to line my trench with a non-woven or woven geotextile. A woven geotextile is going to reinforce that base and it's going to separate the subsoil from our base. But you only want it to wrap up the sides of that trench. You don't want to go in behind the retaining wall with this. A non-woven geotextile is going to promote drainage and separate that subsoil from our base. Now there's two arguments for non-woven geotextile. Do you continue it up the backside of that trench or do you not? The argument against not putting non-woven geotextile up the backside of that trench is that eventually it's going to get clogged and it's going to start to put pressure on your wall from behind it. If you have a lot of silty material in your subsoil, you may not want to do this because that will clog up that non-woven geotextile. If it's a very sandy subsoil, you can go this route. However, you definitely want non-woven geotextile on the very top of your drainage area before you put topsoil on top of this. That's because that topsoil will work its way down into your drainage area and contaminate it. Once our geotextile is in, we can then start installing our base material. There's two different aggregates that you can use for your base, and one you should never use even for your bedding layer. That one is stone dust. Stone dust is a 1/4 inch chip down to fines. It is poor for drainage. It should never be used. Granular A, or 3/4 inch down to fines sand, is a traditional base or dense graded base, and it can be used. Just make sure to add some moisture to it when you are compacting. And if you want an open graded base to let water permeate freely through that base, use a 3/4 inch clear stone. Clear or clean just means there are no fines in it. When it comes to choosing whether or not you use a dense graded base or open graded base for your retaining wall, if you have a lower area than your retaining wall base to daylight your drainage pipe to, open graded base will work, extending your pipe to that lower area to remove all the water from that system. If you don't have a lower area to drain that water to, then it's probably best to go with a dense graded base. And this is going to affect where you place that drainage pipe in behind your wall. Because if you use an open graded base, you're going to want that drainage pipe to sit a little bit lower in your base material, about 4 inches up from the bottom of that trench. But if you use a dense graded base, you want that drainage pipe to sit 4 inches up on top of your base in that backfilled area. And that pipe is always going to go to the back of the trench. Since we're on the topic of that drainage pipe, every 25 feet or so, you're going to want to have a T in the pipe with that pipe outlet coming through the face of the retaining wall. It helps if that outlet extends past the face of the retaining wall so that you can get that water past your base extension, which is that 6 inches in front of your wall block. This prevents water from moving back into your base or slowly eroding away your base in front of your retaining wall. When you're excavating, it helps to set your string line at the top of the initial course that it's going to be embedded so that you can measure down from that string line to the bottom of your trench to make sure you've got your minimum 6-inch base. If you are doing a screed layer, 1 inch, and then 6 inches for that embedded layer to know that you're down at least that 13 inches from the string line down. As you're preparing your base, just refer to your string line to make sure you're down that 6-inch embedded course, measuring down from your string line to the top of the base. Once again, if you do plan to screed, add another inch to that. And when you're compacting, make sure you use a proper compactor for the job. The rule of thumb is for every 1 inch of lift or height of base that you are compacting, make sure that your compactor can do at least 1,000 pounds of centrifugal force. The smallest compactor that you can rent from a rental shop is likely not going to do the trick. You want to get a little bit larger. If you need, get one delivered to you from a rental shop. But the compaction is going to be crucial to make sure that your project is not going to settle. For our base, we want to make sure it is fairly uniform when we're compacting it. We don't want to have it be wavy and have valleys and mountains. We want to make sure our compactor is smoothly going across it. Once again, we're using our string lines to measure down to make sure that we are at the right height for our base. And once you're there, set your screed pipes. We use 3/4 inch interior diameter gas pipes. You can find this at any home renovation store, and set them perpendicular to your trench. That means you're going to need 30-inch pipes or less. And once again, you want to make sure that they are level. Your retaining wall needs to be level. So instead of incorporating a slope like we would with a paver patio, you set one at one side of your trench. Depending on the length of your screed bar, you're going to set that next pipe based on that length, and you're going to level each of the pipes as well as one pipe to the next, front and back. A dead blow hammer comes in handy at this point to slightly adjust each of the screed bars as necessary, or build it up ever so slightly with some of your HPB bedding material. HPB is high performance bedding, or 1/4 inch clean angular crushed chip to 3/8 inch. We dump that material in between our pipes and scrape it back with our screed to reveal a level surface. We then hop our initial screed bar to the next and continue that process throughout our trench for our retaining wall. Before you start laying your retaining wall block on top of this screed layer, just fill in the voids that the pipes have left. Now you should have a completely level surface for you to simply place your retaining wall blocks on. Start from one side of your retaining wall and you work your way down. It's very important to use a string line to represent either the front of the wall block or the back of the wall block, and follow that string line to make sure that your retaining wall is completely straight. If you're building your retaining wall parallel to something such as a fence, measure the front of the retaining wall to the fence and keep that measurement consistent throughout your wall. Place the first wall block and level it front to back and side to side. A 2-foot level helps in this situation, as well as a dead blow hammer to knock down that retaining wall block to get it level. Even if the retaining wall block is completely level when you place it on your screed layer, give it a couple of whacks in the middle of it to set it into that screed layer, and double check one more time it's level before moving on to your next block. Continue this process through that initial layer, double checking also as you move to the next piece that it's also level to your previous piece. Just because one wall block is level and then you set the next one and that one's level doesn't mean that they're level to one another. One could be level but a little bit higher, and in that case you want to adjust it to make sure that it's level with the previous block. Your initial course is going to be the most time consuming, and it's crucial that you get it right, level, and straight, because it's going to affect the rest of your wall. Any higher or low points is only going to get worse as you build that wall up. Once that initial course is set, all you have to do is just stack blocks one on top of the other. Make sure to sweep away any dust or debris on the surface of the block that you're placing. And typically these retaining wall blocks have some sort of clip system with them that you need to install as you build that wall up. This could be a plastic clip that goes in between grooves, or it could be a built-in locking mechanism to the actual concrete retaining wall block. Make sure that each layer is staggered a minimum of 1/3 of that retaining wall. You don't want to stack the same size block one on top of the other, moving your way up the retaining wall. That's not going to give you the segmental retaining wall strength that's required for the wall. As you're building up your retaining wall, you also need to install the backfilled material. This backfilled material should be 3/4 inch angular crushed clear stone. That means there's no fines in it, no sand, and any incidental water is just going to work its way down through that. It won't hold on to water and put pressure on the back of your wall, which is also why we need that drainage pipe in behind our retaining wall, which is a perforated pipe that allow water to enter it and be moved to whatever side of the retaining wall you're going to daylight to. And that pipe needs at least a 2% slope on it. That means 1/4 inch per every foot. When building your wall up, you do need to consider the placement of Geogrid within your wall. This will be specified by the manufacturer's engineered drawings, so refer to that. But you want to use uniaxial geogrid. This means that there's strength in one direction. And when you roll out your geogrid, that strength should go perpendicular to your wall. So typically this means rolling it perpendicular to your wall. It is a mesh-like grid system that gets sandwiched in between your retaining wall blocks and extends into the drainage and backfilled area. And this measurement will be specified by the manufacturer, as well as where in the height of your wall that will go. It stabilizes the material in behind the wall, and typically the higher you go with your wall, the more geogrid layers there are. And it's important to backfill as you build up that wall, because you're gonna put too much pressure on your wall if you do it all at once that wall has been built up. Once you lay a row of your retaining wall, backfill with your 3/4 inch clear, level it, and run your compactor parallel with your retaining wall. Continue this process until you are at the step to which you would install your caps. At this point, if you're installing hardscape lighting or undercap lighting underneath those caps, now's the time to wire those in before adhering your caps on top. Once again, I like to use natural stone caps. So what I do is I dry fit them before adhering, make sure that they are in the spaces that I want them to be. Complete any cuts. I specifically like to make my caps symmetrical. So instead of having one piece on one end be 2 feet and one cap on the other end be 4 feet, I'll make each of those end caps 3 feet. And then I can go back and adhere those caps with a 1 inch overhang is what I prefer, especially if I'm doing hardscape lighting. You need that 1 inch overhang to hide that lighting fixture. I use a hardscape adhesive. I do perpendicular beads to my retaining wall, so if there ever was any water to get its way underneath that cap, it has a way to escape, rather than parallel lines which would trap that water. Additionally, it's helpful if you do cut a drip edge on the underside of the cap before you install them. This is a parallel line about 1/8 of an inch deep to the face of your cap, so that if any water works its way down the face and then underneath the cap, it hits that drip edge and drips down rather than dripping towards your wall and running down the face of your wall, which could cause efflorescence in the future. Efflorescence is a white powdery substance. It's brought out by moisture in concrete, and this can help prevent that. And then finally, we can lay a layer of non-woven geotextile on top of our drainage area. Typically, I like to be 4 to 6 inches down from the top of the cap to then place some topsoil on top to clean things up. Same thing with that base extension. I do like to lay a layer of non-woven geotextile and then place my topsoil on top, making sure I have a slope away from the retaining wall so water works its way away from the retaining wall. And that's it. You have your retaining wall completely finished. Once again, there's videos on every single step of the process in detail in the link in the description below. If you have any questions, refer to those videos, learn more, or leave a comment in the comment section. I'll respond to anybody and everybody. Like this video if you found it helpful for whatever reason, and subscribe to this channel for more hardscaping content like this. Thank you so much for watching.